The purpose of this video is to give you an introduction in LTSpice. LTSpice is the circuit simulation software we are going to be using for this class. If you have not yet downloaded it and installed it on your laptops, you should try to do it before you come to class. You can find the links on the class website. If you go to the class homepage and click on the software link, you're going to see the option for LTSpice 4 or a newer version in LTSpice 17. You can click one of them, go to the analog devices page where you will see an option for LTSpice on the left over here. And if you click on that, you're going to see an option for you to download the software for a Windows or a Mac. You can download it and install it before you come to class so that you can save time and just work on the lab. Okay, when you start LTSpice, the interface is going to look something like this. And to create a new schematic, we go under File, say New Schematic. It's going to give you a blank page where you can drop circuit components, simple circuit elements, draw wires, connect them, and then later simulate for obtaining interesting voltages and currents. So I'm going to draw up a very simple circuit diagram with one voltage source and a few resistors. I'm going to label the nodes, and then I'm going to simulate that for I'm just going to run a DC simulation. So in order to grab a voltage source, you're going to have to look at a specific component. Click on the component option right here. You will see an option for voltage source, voltage. This is for all types of sources, an AC source, a DC one as we are going to be using. You say click OK. This is going to give you an option to place a voltage source. You place one voltage source, and we are going to just need one for this example. If you don't need any more, you just escape out of that. You can zoom in and out on your circuit by scrolling up and down. That's enough. Now I'm going to choose some resistors and drop them on my circuit. There is a resistor option over here. It's going to give me a vertical resistor. I can rotate it by using Control R. Let's say I want R1 over here. Say I need another resistor over here, and say I need another resistor over here. And I'll add one more over here. Now I need to connect them using a wire. So I'm going to grab the wire option from here. I'm going to click once on one end of V1. Click again over here so that it can bend. Click on the resistor. I'm going to do that same thing for my entire circuit so that everything is connected. Now I need to assign nodal voltages, but before I do that, I'll assign a ground to this circuit, which is going to be our reference node. There is a ground option over here which I can click. It's going to give me a ground symbol. I can drop that right here and then connect it to my circuit using a wire. Now for placing node voltages or identifying nodes and then placing node voltages, you are going to have to click on this label net option and then select a label name. Let's say we want to call it VA, VB, VC, and so on. So I'm going to pick VA, and then I'm going to put it at the first node I notice. I notice that V1 and R1 intersect at that particular point, and I'm going to have to click on that particular wire to place a node over there. And then I'm going to place another node over here, and the third node for my circuit can be here. And of course our fourth node is ground, which is already present in our circuit. Now these three nodes have the same name. Let me change this to say VB, and this can be VC. So these are going to be my three nodal voltages, and of course the ground at the bottom of the circuit for convenience. Now I can change the values of R1, R2, R3 and R4 based on the circuit diagram that I'm trying to simulate. Right click on R and you can change this to say a 1 kilo ohm resistor. This can maybe be another resistor of value say 2K. This can be another 1 kilo ohm resistor, and say this can be a 3 kilo ohm resistor. All my resistors have names as well as values, so that's good. Now this source V1 doesn't have a value for how much voltage it's going to supply. So for this independent voltage source, I'm going to choose a value of, say for example, 12 volts. I'm going to right click on V and change that value to 12 volts. Now everything in my circuit looks good. I'm ready to run a simulation, a DC simulation. So in order to run a simulation, I'm going to have to look at an option which allows me to do that. I'm going to click on the run symbol, or you could also go to simulate and then click run. Once you do that, it's going to give you an option for running a transient simulation, an AC simulation, and a bunch of other options. We are trying to look for a DC operating point or a DC simulation option. Once you click on that, it is going to give you this command which you can place anywhere on your circuit. And once I say OK, it's going to give me all the results that I'm interested in. So all the voltages and all the component currents. So over here I noticed that V1, the voltage source, should be the same as VA, which it shows as 12 volts, so that makes sense. VB, the node voltage at this point, is reading as 6.857 volts. VC is reading as 5.158 volts, and you also have all the currents that are flowing through various elements in our circuit given to you over here as well in amperes. Now one question that we can ask at this point is, what is the voltage across R1? Well, R1 is between nodes A and B, where the node voltages are VA and VB, and we have simulated those voltages and we found them to be 12 and 6.8. So the voltage across R1, or the voltage difference, would be VA minus VB. So that would be the difference in potential. So it should be 12 minus 6.8, so it should be about 5.2 or something. Alright, I hope this video helps you to get a quick start in simulating circuits with DC sources and a few resistors, and running a DC simulation to obtain nodal voltages and currents.